The DJI ban is now in effect, meaning all future DJI products are restricted from entering the US market. In this video, we want to pay an X-ray homage to our favorite DJI products here at Creative Electron. This is the DJI mic. On X-ray, you can clearly see a multi-board architecture designed to separate audio processing, power management, and wireless communication. The antenna system is physically spaced from noise-generating components to preserve signal integrity. The transmitter also includes onboard flash memory, allowing them to record audio internally. This is a DJI Mic Mini, another one of our favorites here. The X-ray shows a single tightly integrated system where the battery, RF front end, audio processing, and antenna all coexist within millimeters of each other. To achieve this level of miniaturization, DJI engineers made deliberate trade-offs. One major trade-off was the removal of onboard audio recording in the transmitter. The Mic Mini relies entirely on live wireless transmission, which simplifies internal architecture and reduces size and weight, but it requires even more finely tuned transmission protocols and signal engineering. At this scale, even the human body absorption comes into play. The antenna is no longer a separate structure, but a precisely tuned trace integrated directly into the PCB geometry. Shielding is applied only where necessary, because every fraction of a gram matters at this scale. This is not just shrinking parts, this is re-engineering the entire system around the physics of RF signal processing. Now we move from sound to flight. This is a DJI Mini 4 Pro, a sub 250 gram aircraft that represents the peak of DJI's consumer drone engineering. Our X-ray reveals a highly optimized airframe designed to be stiff, lightweight, and aerodynamically efficient. At the front, you see a true mechanical 3-axis gimbal, not just digital stabilization. Each motor, bearing, and flex cable works continuously to isolate the camera from the motion and vibration. Behind the gimbal is a CMOS sensor capable of native 4K HDR video. Dedicated image processing hardware sits close to the sensor to reduce latency and electrical noise. Unlike earlier Mini models, the Mini 4 Pro includes omnidirectional obstacle sensing. Our X-ray shows multiple vision sensor modules placed around the aircraft, each adding weight, wiring, and processing complexity. Despite this, the drone remains under the 250 gram threshold through aggressive structural and electronic optimization. The battery is shaped to act as a structural element, not just a power source. At the center of the aircraft, you see stacked circuit boards housing the flight controller, inertial measurement units, and navigation radios. These boards are vertically integrated to shorten signal paths and tightly control the center of mass. The RC2 is not just a remote, it's a self-contained wireless command center, combining display, processing power, and RF systems into a single handheld device. Unlike phone-based controllers, the RC2 integrates a dedicated display, eliminating cable latency, connector wear, and external device variability. Internally, the controller uses tightly integrated processing boards designed to manage bidirectional command, telemetry, and high bandwidth video in real time. The radio dynamically adjusts frequency modulation and bitrate to maintain a stable link in an already crowded spectrum. The wireless architecture is one of the most sophisticated systems inside these devices. It is also the system most heavily scrutinized by regulators. What we're seeing in these X-rays is not just typical consumer electronics. This is aerospace level systems engineering condensed into palm-sized devices. Subscribe for more X-ray content and let us know in the comments what your favorite DJI product is. Thanks for watching.